Assalamu alaikum and welcome to our 9th video of our first chapter, number systems. In our previous classes we have seen how to locate some irrational numbers such as root 2 and root 3 on the number line. In today's class we will be learning one more irrational number such as root 5 and we'll see how to locate that on the number line. So let us start by locating root 5 on the number line. The procedure is very simple. So we'll have to first take a number line. And this will be 0, this is 1, 2, 3 and the number line can continue up to any number that you want. But the requirement is only of few numbers here, so therefore we won't be taking a large amount of numbers. So what we'll have to do here is, one rule to remember, just like how we did in root 2 and root 3, the spacing between these numbers has to be same. Proper distance between each number should be there, otherwise you will not get accurate values. So what you'll have to do is, for root 5 it's a little different. You'll have to take 2 units. When I say 2 units, when I say 1 unit it will be 0 to 1, and when I say 2 units it will be 0 to 2. So mark this point as A and the number at 2, which is B. So you have taken 2 units. So after taking 2 units, measure 1 unit with the help of your compass. When I say 1 unit, it will be from 0 to 1. Measure 0 to 1 with the help of your compass. Keep the compass pointer here. Otherwise, before that, you can draw a line, a straight line of any measurement you want. Whenever we draw a straight line, it is always easy to cut an arc. So draw a line first and then cut an arc. So measure 1 unit, which is 0 to 1. Keep the pointer of the compass here and cut an arc here. Whatever distance has come, keep it here and cut an arc of the same distance. So this is 2 units and this will be 1 unit. Is that correct? 1 unit because we have taken 0 to 1. And after that, join up to this point and call this point as C. So you have joined AC. You may ask that why in previous problems we took only 1 unit and why are we taking 2 units for root 5. So when I do Pythagoras theorem as my next step, you'll understand why did we take it as 2 units instead of taking as 1 unit in previous problems. So once that is over, of course the construction is not completed. What we have to do next is, we have to keep the pointer of the compass here and drag our compass up to C, take this full measurement with the help of compass, and from C we will cut an arc like this, right? So this point exactly will show us that this represents root 5. So this arc represents root 5. So what I should do is, I should now prove that this side is also root 5 by making use of Pythagoras theorem. So I have got a right angle triangle here, this triangle. So this is B, C and A here. B is at 90 degree. So this is 1 unit and AB is 2 units. I should prove that this will be equal to root 5 because that is in the question. So what we will do is, let us apply Pythagoras theorem, which is the hypotenuse here, AC. We have learned how to use Pythagoras theorem. You can refer to the previous videos if you want more clarification. AC square is equal to, which are the other two sides? AB and BC. So that will become AB square plus BC square. So AC square is equal to, the value of AB is 2, so that becomes 2 square, plus the value of BC is 1, that becomes 1 square. So AC square is equal to 2 square is 4 because 2 into 2 is 4, plus 1 square is 1, 1 ones are 1, and AC square is equal to 4 plus 1 is 5. So AC is equal to square, when you shift on the other side it becomes root, so we get the answer as root 5. So the value of AC is root 5 and we have now proved that root 5 can be located on the number line. So let us quickly for few seconds see what steps did we do for constructing or locating root 5 on number line. We took a number line first with proper spacing between each number, exact spacing between each number. Once that is over, we selected 2 units. Now you understood why did we take 2 units, because if I don't take 2 units I will be not getting the answer as 5. So I will take 2 units, that is from 0 to 2, name it as A and B, then draw a straight line at B. Take 1 unit measurement, that is from 0 to 1, keep the compass on B and cut an arc on that straight line, then join A and C. then measure with the help of your compass from A to C, and from C cut an arc, and this point will give us root 5. We have to prove the same thing with the help of Pythagoras theorem. So we take a right angle triangle here. So AB is 2 units, so I'll write 2, and BC is 1 unit, so I'll write 1. I should prove that the value of AC is root 5. How to use Pythagoras theorem? We always take the hypotenuse. Hypotenuse is the slant side of the largest side. Largest side here is AC square is equal to AB square plus BC square. AC square is equal to the value of AB is 2, so that becomes 2 square, plus the value of BC becomes 1, so that is 1 square. So AC square is equal to 2 square is 4, plus 1 square is 1. AC square equals 4 plus 1 is 5, and square on the other side becomes root. Therefore, we have proved that the value of AC is root 5. This is how we construct root 5 or locate root 5 on the number line. Please do practice this, and after you have practiced, you can click the pictures of this and send it to me on the Google Classroom app. We have one more question remaining in exercise number 1.2, which will cover and finish off with irrational numbers, so that we can start with a new topic in the next class. So let me write the question that is remaining, and I want you to think about the answer after I write the question. So the question is R. So this is second question in your exercise 1.2. You can also include root 2, root 3 and root 5 in the same exercise, no problem. Are the square roots of all positive integers irrational? So this is the question. Are the square roots of all positive integers irrational? This is a question that is continued after this. There is no need to write. I'll explain it along with the solution here. So first of all, let us see what are positive integers. Positive integers are plus 1, plus 2, 3, 4, right, like that. So even if you don't write plus sign, all these are still positive integers. So telling the square root of these numbers irrational. So that means if you take the square root of these numbers, will you get only irrational numbers, right? So the question is very simple. If you take all positive integers and then take the square root of those numbers, will you get the answer as only irrational numbers? What are irrational numbers? Numbers which can't be written in the form of p by q, right? So if I take the square root of 1, what is the square root of 1? 1 only, because 1 ones are 1. Square root of 2, there is no square root of 2. So square root of 2 will be square root of 2 only. Square root of 3, no square root of 3. So it has to remain as it is. But what is the square root of 4? 2, right? How is the square root of 4? 2. Let us see. 2 square is 4. That means 2 2s are 4. That's why 2 square will be 4. If you shift the square on the other side, 2 is equal to square on the other side will become 4. We have learned that in Pythagoras theorem. That means square root of 4 will be 2. So now this number and this number, are they irrational numbers? No, because 2 can be written as 2 by 1. What are rational numbers? Numbers that can be written in the form of p by q. That means if you take all positive integers and take the square root of those numbers also, there are some numbers for which there are square roots, and those numbers can be written in the form of p by q. That means all the answers that we get here are not only irrational numbers. So according to the statement, they are asking, are they only irrational? So the answer will be no. They are not going to be only irrational. They can also be rational numbers. Let me take one more example. When I say root 5, there is no square root of 5, so it will be irrational only. But when I say root 9, what is the square root of 9? 3, because 3 3s are 9. So is 3 an irrational number? Is 3 an irrational number? Definitely no, because 3 can be written as 3 by 1 and that will be in the form of p by q. So according to this question, even if we take the square root of all positive integers, the answers that we may get can be rational or irrational. They can't be only irrational numbers. So I am not going to give you the reason for this. I want you to write the reason for this along with some examples. So try to write the answer for this in your own words by looking at the explanation that I have given. That's all for today's class, and in tomorrow's class we'll be starting a new topic. I hope you have understood how to construct root 2, root 3 and root 5 on number line. Please let me know if there are any doubts. Thank you very much for watching the video.